Alright. Assalamualaikum warahmatullahi wabarakatuh. This is the presentation of our group. Our group content Arifatul Najwa, Adriana Nur Izzati, Aisyah Shafia, and Fahda Anati, and Nur Amira Liana. We will explain about Fourier transform in spectroscopy. Okay, next slide. Okay, what is Fourier transform? Fourier transform is a tool that break a waveform in a function or signal into a alternate representation characteristic by sine and cosine wave. It also used to transform a time domain signal into the frequency domain. Fourier transform also can show that any waveform can be rewrite as the sum of sinusoidal function. Okay, next slide. The application of a Fourier transform in electrical engineering. Fourier transform can derive the Spatial technique to non-periodic function. In Fourier transform, the Ohm's law is still valid. To apply Fourier transform to circuit with non-sinusoidal, the same way apply phasor technique to sinusoidal circuit. Next, the 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 Fourier transform can use circuit techniques such as voltage division, source transformation, mesh analysis, node analysis, or Thevenin theorem. It can find the unknown response. Voltage to transform the function of circuit element, and also Fourier analysis cannot handle circuit in internal condition. For the future explanation, I will pass to Aisyah Safia.
Hi, Assalamualaikum. My name is Asha Safia. Okay, today I'm present about electrical engineering. The Fourier transform generates that phasor techniques to non-periodic function. There we apply Fourier transform to circuit with non-sinusoidal excitation in exactly the same way we apply phasor techniques to circuit with sinusoidal excitation. Thus, Ohm's law is still valid. Where V omega and I omega are the Fourier transform of the voltage and the currents, and Z omega is the impedance, we get the same expression for the impedance of resistor, inductor, and capacitor as in phasor analysis. We transfer the function for the circuit element into the frequency domain. The Fourier transform of the excitations, we can use circuit techniques, use a voltage division, source transformation, mesh analysis, node analysis, or Thevenin's theorem to find the unknown response currents and voltage. Finally, we take the inverse Fourier transform to obtain the response in the time domain. Although the Fourier transform method produces as a response that exists, Fourier analysis cannot handle circuit with initial condition. The transfer function is again defined as the ratio of the output response y omega to the input excitation x omega. Next. Okay, the input-output relationship of a circuit in the frequency domain y omega equal to h omega x omega. The frequency domain input-output relationship is portrayed at equation figure 4. equation in figure 5 show that if we know the transfer function and the input, we can readily find the output. The relationship in equation at figure 3 is the principal reason for using the Fourier transform in circuit analysis. Notice that h omega is the identical to hs, which h equal to j omega. Also, if the input is an impulse function, for example xt, equal to delta t, then x omega equal to 1. So that the response is y omega minus h omega minus f times ht, indicating that h omega is the Fourier transform of the impulse response ht. This is an example, a summary of some Fourier transform pairs. Next. The example, the calculation is to find the VOT in the circuit of figure 7 for VIT equal to 2 exponent the power of negative 3t times 2ut. The solution is the Fourier transform of the input voltage is Vi omega equal to 2 divided by 3 plus j omega, and the transfer functions obtained by voltage division is the equation is h omega equal to V omega divided by Vi omega equal to 1 divided by j omega divided by 2 plus 1 j omega equal to 1 divided by 1 plus j to omega. Also can use by partial fraction if VO omega equal to negative 0.4 divided by 3 plus j omega plus 0.4 divided by 0.5 plus j omega. The taken inverse Fourier transform yields VOT equal to 0.4 to e the power of negative 0.5t minus e the power of negative 3t times 2ut. That's all.
Okay, next slide. Okay, I will continue for my part. Okay, Fourier transform, or we call as FT, is useful in the study of solution of partial differential equation to solve initial boundary value problems. So there are many applications that can use in a variety of fields such as optics, geology, spectroscopy, acoustic, computer science, and medical. So for this assignment, we choose Fourier transform application is spectroscopy. Okay, so what is a spectroscopy? Spectroscopy is a study of the observation and emission of light and other radiation. It is by method as related to the dependence of these processes on the wavelength of the radiation. More recently, the definition has been expanded to include the study if the interaction between particles such as electrons, protons, and ions. It also as well as their interaction with other particles as function of their collision energy. Next, the spectroscopy also has been crucial in the development of the most fundamental theories, which is in physics, including quantum mechanics, the special and general theories of relativity, and also quantum electrodynamics. It also has been a key tool in developing scientific understanding, not only for the electromagnetic force, but also for the strong and weak nuclear forces. Uh, Fourier Fourier transform spectroscopy also is a measure technique, which is spectra are collected based on measurements of the coherence of a radiative source. Okay, this is some of application on spectroscopy. First, determining the atomic structure of a sample. determining the metabolic structure of a muscle, monitoring dissolved oxygen content in fresh water and marine, studying spectral emission lines of distant galaxies, altering the structure of drugs to improve effective characterization of proteins, space exploration, and also respiratory gas analysis in hospital. This is an example of a spectrum graph and also an interferogram from a Fourier transform spectrometer. For the spectrum, it is a light emitted by the blue flame of a Bruton torch. The horizontal axis is the wavelength of light and the vertical axis represented how much light is emitted by the torch of the wavelength. The interferogram, which is raw data on a Fourier transform into an actual spectrum. So the peak at the center in the ZPT position, which is called as zero path difference. Here all the light passes through the interferometer because its two arms have equal length. Next slide. Fourier transform spectroscopy, as I mentioned before, is a major technique whereby spectra is collected based on measurements of the coherence of a radiative source, which is using a time domain or space domain measurements of the electromagnetic radiation or other type of radiation. It also can be applied variety of types such as including optical spectroscopy, infrared spectroscopy, or called as FTIR, nuclear magnetic resonance, NMR, magnetic resonance spectroscopic imaging, MRSI, mass spectrometer, and also electron spin resonance spectroscopy. There are several methods for measuring the temporal coherence of the light, including the continuous wave called as Michelson or Fourier transform spectrometer, and the pulse Fourier transform spectrograph, which is more sensitive and has a much shorter sampling time than conventional spectroscopic technique, but is also applicable in a laboratory environment. For the continuous wave, called as Michelson or Fourier transform spectrograph, the Michelson spectrograph is similar to the instruments used in the Michelson-Morley experiment. Light from the source is split into two beams by a half silver mirror. One is reflect off a fixed mirror and other one of a movable mirror which introduce a time delay. The FT spectrometer is just a Michelson interferometer with a movable mirror. The beams interfere following the temporal coherence of the light to be measured at each different time delay setting. It's also effectively converting the time domain into a spatial coordinate. By making the measurements of the signal at many discrete positions of the movable mirror, the spectrum can be reconstructed using a Fourier transform of the temporal coherence of the light. Next is also capable of very high spectral resolution observation of very bright source. Because the Michelson or Fourier transform spectrograph was popular for infrared application at a time when infrared astronomy only had single pixel detectors. For the imaging Michelson, are a possibility, but in general have been supplanted by imaging February period instruments which are easier to construct. This is a figure for the Fourier transform spectrometer. It is just a Michelson interferometer, but one of the two fully reflective mirrors is movable and also allowing a variable delay, which is in the travel time of the light to be included in one of the beams. Okay, that's all from me. Now I pass to Amira Liana.
Okay, this is thank you, Arifat Najwa. I will go to for the calculation formula. So this is a fine calculation AF that used to be a finite amplitude equal to the amplitude of the fixed mirror beam, is it A1 plus A2 equal to the amplitude of the moving mirror beam, and also the optical path difference. Also lambda is wavelength and n is 0, 1, 2, 3 and any integer. Okay, next is for spectroscopy's work. Spectroscopy is the analysis of interaction between any part of the electromagnetic spectrum. When the electromagnetic radiation emits through a sample or image that interact with the sample, it can be absorbed, reflect, and refracted, and so on. The absorbed radiation affect the electron and chemical bond in the sample. Spectroscopy can see how the irradiation of the incident is able to affect the sample. Okay, when the radiation is emitted at the spectrum is absorbed, it allow it to obtain information about the material because because the interaction depends on the wavelength of the radiation. Okay, next is used to develop of chemical process. It also can be used to measure the effect of electromagnetic radiation on a sample. Uh, this is allow this allow it to be used to determine the duration of exposure to the radiation sources. Okay, next I will pass to Ariana Noizati.
Okay, move to spectroscopy and spectrometry. Spectroscopy means to study the electromagnetic radiation produced the interaction between systems in a non-destructive manner. For spectrometry, means to measure the measurement of electron radiation to obtain information about the system. Next, for summary, has a wide range of help in various fields like optics, geology, spectroscopy, computer science, and medical. Also determine functions of signals in mode variation. Function of direct space can be exponentially as a complex value function of reciprocal space, that is frequency sometimes called as a Fourier space. Fourier transform infrared spectroscopy analysis use the infrared spectrometers within the world and gather in high spectral resolution data. Fourier transform also useful in various applications range from experiment analysis methods, and it is necessary and large that solid foundation in understanding the time domain, frequency, and domain relationship with communication signals. That's all from this topic of transform in spectroscopy. Thank you.
Thank you. That's all from our group for presentation, video, assignment and work analysis for the topic Fourier transform. Thank you.